Hello, hello. Well, hello. Welcome to this session by a very special speaker, Ian Darwin from Reg Minette Group. He actually, I found out too, is so honored. He's the very first Java champion. So very special. I feel so, even honored to be hosting him. Yeah, so he'll be telling us about some neat things to know about modern Java. So let me do a really quick introduction as well. So he has used Java since before the 1.0 release and wrote arguably the first commercial Java course outside Sun and was the first member, as I mentioned, of the Java Champions program. And he wrote the O'Reilly Java Cookbook and do desktop and mobile apps, but he doesn't do websites. And lives out in the country north of Toronto, where his wife and the three wonderful children were raised. And in fact, that's the three letters of his children's name is actually formed the name of his company. That's a very special one. So when the children were younger, they raised chickens, and which indirectly accounts for the rooster on the cover of the Java cookbook. So that's a very good to know. And so now we have Ian on the stage. Yeah, enjoy, everybody.
Well, good morning or good afternoon, depending on what time zone you're in. Welcome, everybody. I'm glad you're all here. Thanks, Mary, for that introduction. I'll try to live up to it. Being the first Java champion was just the luck of the draw. Aaron from Sun back in the day walked around the show floor looking for a few people, and I happened to be the first one he stumbled across. So it's not anything terribly super about that. But anyway. I do teach a lot of Java courses, and my big bugaboo, my one disappointment is that when I hear that people are forced to stay on Java 8, or I even had one recently that said Java 5, if you can believe that, for various reasons like app server compatibility or management or maybe mismanagement. There's just so much cool new stuff in Java since those days, and I'm glad to be able to tell you here about some of it, some of my favorites. This talk was going to be called 7 Stars from 7 Javas, but one of the 7 got kind of axed, so we're down to 6, and so I changed the title around a little bit. It's kind of a riff on a movie title from the 1970s or 80s, which you might or might not recognize. You can put it in the chat if you do. I changed the title 6 or 7 times, and I might change it again before it's final. But anyway, let's talk first about the one that got away, which is the feature that got sent to the gallows by the rabble. Turned out it was this one. It's called string interpolation. And it's a feature that's in many other languages. It's a very good mechanism for formatting strings because you can simply take any variable, or in fact any expression, and put it into a string using this slightly quirky syntax of backslash curly brace expression close curly brace. No backslash on the close curly brace. And I'm going to show a bit of code from this, even though it's been withdrawn we hope temporarily. And so without further ado, let me launch over to here. And so assume that we have a user class someplace called, wait a minute, this isn't showing. Why is that not showing? Oh dear. This is showing on my screen, but it looks like, oh, I'm sorry, it is showing, isn't it? Let me switch windows again to there. Yes, it is showing. I'm sorry, I was fooled. I've been fooled. Won't fool me again. Here we go. So we need to get into the correct project. And here we are. So assume that we have a user class and we construct an instance of it. It has three fields: a username, holdings, it's a financial enterprise, how many shares you have in a particular cryptocurrency. Everybody seems to be inventing their own cryptocurrency these days, and I didn't want to be left out. So Ian Coin is my own new cryptocurrency, but you can't buy yet because I haven't invented it yet. Anyway, and the last time the user logged in. Those are the three fields. So then we just do print line of welcome user.name, where user is just a variable in the current scope, and .name is just a field within it. Now, there is a str at the front of it, which is to tell Java that it is a string template. And that's the only syntax that's needed apart from the curly brace pair. Now, it's not limited to just picking up values. It can be expressions. So inside the curly brace, you can do a multiply, for example, number of holdings times the current price. And this one is a little bit longer. We haven't seen you in period between user last login, local date now, get days, number of days. And if we run it, we see welcome, your name, your holdings are worth so many Ian coins, and we haven't seen you in 10 days. So all of those just work out of the box. And that was working in Java 21 and 22. Now, besides str, there's another formatter. Actually, there's one more example here of a longer string. And this kind of introduces string blocks, text blocks, multi-line strings, which we'll say more on later. But here is a long string, and we're just interpolating a few values into it, which in this example are hard-coded, but you can imagine they're probably coming from a resource file that is internationalized. So we can make this exact same page work in any language that we have internationalization support for. And there's another kind of template called FMT. And there I did an import of it just to show you the full class of it, Java util format processor.fmt. And it also takes a string template, but this one is a bit different in that it has at the front of it, it has a format string using printf formatting. So where's printf? Printf was invented, if you can guess the decade printf was created in, you're probably doing well historically. Invented in about 1973, this little formatting language has survived pretty much unchanged. It's grown a little bit, but it's still there from the earliest Unix system in the world at Bell Labs. It just grew out from there. It's in all modern languages, including, it's already in Java in the string.format method and the format class. But here it's being added to string templates using FMT. Now, those two are pretty powerful in their own right. But of course, string format processor is a public interface or class, I forget which. So you can build your own. And the original documentation for this provided the source code for one for generating syntactically correct JSON from printouts, and another one for doing type-safe SQL to avoid SQL injection attacks, which if you don't know what SQL injection attacks are, you need to learn if you're doing anything with any database stuff. So you could write your own for almost any format, any particular type of language or type of output. Well, that's the syntax they came up with. A couple of bad things happened. One is there was a lot of bike shedding on the mailing list, none of it very productive. And that's why I had the gallows with the rabble, huge crowd out front of it on the other slide. And Let me just switch back to that. In fact, that's a good point. Good thing to underscore this with. So there's a lot of bike shedding and people complaining about the syntax and saying my way is better and argumentation and stuff. So anyway, what really happened was that inside Oracle, they tried using it on a really large project. And they haven't said much about this, but they just said it didn't work for us. And so it's been withdrawn. It's not in Java 23 at all. And that's what I meant by it being axed. But they never said it's completely dead. And I think the theory was that they're going to go back and work on it for a while longer. So hopefully it's like Neo and Trinity, just waiting to be resurrected. And I hope we don't have to wait 60 years for the sequel. I'm hoping it'll come back. That's all I can say. That's all I know. Now, they removed this from Java. What about backwards compatibility? They've always said that Java would be fully backwards compatible. It turns out that the string template mechanism was always marked as what's called a preview feature. Like several of the features I'll cover today, preview features are not committed. So they're allowed to change them or even withdraw them, although I believe this is the only one they've ever withdrawn. They're supposed to be, even though they're not committed, they're supposed to be, quote, nearly ready for production. That's a quote from Oracle. They're put out there for developers to play with and give feedback on. And it happened, the most important feedback came from inside Oracle. To use these preview features, you just have to have a JDK of the correct version. And if you're running from the command line, you have to give a couple of arguments, --enable-preview and --source with a number, the number of the version that you want the preview from. That's kind of tedious. So if you're doing a lot of command line work, you'll probably make a shell alias or batch file or something. When you're running with the Java command, you only have to give the enable preview because it already knows what source it was compiled for. If you're using an IDE, you only have to do it once. In IntelliJ IDEA, you go into project structure, select the JDK, and drop down to the preview, because it's if you have a bunch of JDKs installed, the previews are going to be at the bottom of the list. And you probably should have a bunch of JDKs installed if you're doing modern Java development, because these features change over time and you want to keep up with them. So do go ahead and install, Java 21, Java 22, 23, maybe even 25 if it's out yet. I think there's an alpha of it out if you want to play with that. When you're doing that, if you look at any of these features that are in preview, you're encouraged to give feedback. The features are documented originally in a JEP, Java Enhancement Proposal, and each JEP has the address of the mailing list for sending comments on that particular JEP. So do put thoughtful comments in. Saying I don't like it, it doesn't help, but if there are specific things that you think could be improved and how they could be improved, that'll be helpful to get that feature into production and be able to use it without telling your management that it's a preview. JEPs are numbered, and you can find them just by doing a web search. Beware when doing that the JEPs keep their name, but they change JEP number as they move from one version of Java, like 21 to 22. They'll be the same title, but a different JEP number. So make sure you're getting the latest one or the correct one for whatever version you want. The other thing that's happened over time is that the release cycle has been shortened. If you were around in the early days, it was often several years between releases. Now it's down to 6 months. And it's like clockwork. Every 6 months, there will be a new release of Java going forward. They've been doing that for several years now, and it's working. And it is, in fact, what gives them the flexibility to make changes. If something is in preview and enough people don't like it or it turns out to be broken, they can fix it and get it back out in the next release within the 6-month cycle. So that's really good. There is another type of incubation, of non-committed mechanism called an incubation, and this is even less final. Preview features, for example, show up in their final package, even though they're in preview, like you saw one example of that. Incubation features are in a special namespace, jdk.incubation.whatever, and you have to use a similar command set to enable them. There's one called the Vector API, which allows for parallel operations on CPUs that support it. Suppose you have a long array of numbers and you need to do some operation on all of them. The vector set allows the hardware to break them up into chunks and do a bunch of them in parallel. This is part of the Vector API. By the way, it's now in its 8th incubation, which I think is a world record, or a Java record anyway. The Vector API needs a CPU with what's called SIMD, SIMD, single instruction multiple data, and SIMD in turn is part of SSE, these are acronyms you may see in CPU descriptions. SSE stands for streaming SIMD extensions. So the hardware people, AMD and Intel, keep adding to the capabilities, and those letters keep changing. SSE3, SSE4, SSE2, whatever. One other thing that happened was that at the beginning of this 6-month cadence, or slightly before it, the entire code base for Java, which includes the JVM, the compiler, all the other tools, and all the standard library and a few other bitsies, was consolidated into a single large repository. Before that, they had kept the JDK in one, the JVM in another, the library in another, and so on. There were 5 or 6 repositories. They merged them into one and put it on GitHub. So you can, in fact, download all the source code of JDK and build your own version of it. In fact, there's a number of organizations that do that. So you're no longer limited to getting your JDK from Oracle. You can get it from Eclipse Foundation, Azul. There's a whole bunch of different vendors that make their own versions of it. They're all fully compatible. Some of them are faster than others and so on. And if you want to play with it or see how any of it works, go download it, get it, look at it. Since some of you may be using very old Javas, or maybe like people who come to my course sometimes say, well, I learned Java like 15 years ago in college and I haven't used it much since. Hopefully not too many of you are in that situation, but if you are, there's a few things that I am taking for granted. And these are things that were in Java 8-ish era. So I'm not going to say much about these. I might use them occasionally. In Java 8, they introduced streams, lambdas, which are short little mini function expressions, the new date and time API, default methods and interfaces, and that gave them the ability to add a for each method into the list interface. These should all be old hat if you're working actively in Java. The file class, which gives you file information, is being supplanted by the files class in java.nio.file, which can do a lot more, includes reading, writing, and copying. In fact, almost all of your regular text file I/O can be done in 1 or 2 lines with this. That's even older hat. That started back in the days of Java 1.7, before they started using numbers without the 1 point at the front of them. Java 9 brought us the module system JShell, the read, evaluate, print loop, and that's also old hat, just mentioning it for completeness. The code, all the example code that I'm showing is available. These are the codes you were looking for. There's the GitHub for them. GitHub, my name, and then 6 gems code for 6 gems from Java. So the next section is designed, a number of things that are designed for building a faster on-ramp. And by on-ramp, we mean what people have to go through when they're getting started with Java. People either learning programming with Java or learning Java from some other programming language. There's a number of features here that are very helpful in that regard. Something called instance main is simply a main method that doesn't have the static modifier, doesn't have to be public, and doesn't have to have a string array args. So those are three things that were probably drummed into almost everybody here when they were learning Java, that you always have to have that in your main method. Well, goodbye, no longer true. Drastic simplification, much easier to explain to students and to developers coming from other languages. Typical Java introductory course has to either cover all of that stuff at the beginning and basically scare people off, or hand wave over it and say, this isn't important, we'll cover it later. Now you can just omit it. When you're teaching or when you're mentoring new developers, you not bother with all that stuff. It is a preview at the moment, but it's expected to become final pretty darn soon. Naturally, we have code. I have all of my demos in separate projects within that GitHub repository that I gave you, and that's because they have different requirements for preview and release and so on. So starting with instance main, this is a complete program, public class instance main, void main parentheses. That's all you need for your main signature. And then you can have whatever you need in there. So that's not all that exciting, but it's a big simplification. Well, what if you don't even want to have to tell students, for example, about classes in public yet? Well, it turns out you don't have to, because there is even something called classless main, which is a main method that doesn't even have a class around it. No package, no class, just void main. So that is kind of at this very much at the same level, in fact, even less baggage than Python, where you often have that if name equals main, and then you have to talk about underscore variables and stuff. Here it's just void main. You can say void means doesn't return a value and move on and get into the nitty-gritty of the actual code. This is a big win. The one limitation is that classless mains do not get a package. They're always in the unnamed package. You can't put a package statement on them. Class ones that have a class statement you can, but the simplest ones, no package. No package needed. What is the package then? Oh, sorry, what is the class name then? The class name is coming from the file name in that case. And since file names don't have to have any particular case to them, you can see that my classes actually are lowercase names, and they just work. So that would create a, well, let's actually show you. Here is, we call get class and call get name on it. And I'm going to run that guy. And sure enough, it's just the file name. What is class name.java produces a class called what is class name. So good stuff there. A further simplification in Java 4 is 24 is a new class called javadoc, kind of unimaginative, java.io. Capital I, capital O. And what it's good for is it has three methods in it that simply delegate to the corresponding methods in the regular I/O. But guess what? Print and print line and read line are those three methods. So you can have a void main and a print line and a read line and another print line with the result of that. So that is really a rapid, high-speed on-ramp. In fact, this package is called This project subproject is called rocketing because I had originally had a rocket for the logo for it. This one I can run. So it says hello world, and then it says enter your name. It's waiting for me to type your name. I'm just going to be sarcastic and type your name here. And it says thank you, prints out your name. No imports needed. Java.io gets statically imported, and it's 3 methods: print and print line and read line are all automatically available. So this is really cool stuff for helping people get started. One last bit here is that if you're on a Unix operating system, which includes Linux, Mac OS, Unix, etc., BSD, etc., any of those, basically anything other than Windows, you can use what's called a shebang line. Shebang is this 2-character string hash mark exclamation mark. But geek people like to make names for things, so the hash got nobody knows for sure whether it's the shebang part, or the sh part comes from hash or from the shell. But anyway, and bang for exclamation mark. You have to give the full path of something that can be run, and that's how you run this thing. This uses the Java NIO read all lines to read all the lines from a file that's present on all systems other than Windows, and tells you how many entries are in it. Now, it won't let me run it in the IDE because it is not, as it says, located outside of the module source. But not a problem, because I can just run it as a command, assuming I have my path set correctly. Just run it like any other command line command, and away it goes. So in that time, it compiled this and ran it, read all the file, and counted the entries. Notice I have the imports for IO exception and file commented out because they are not needed in classless main in Java 24. Those are imported automatically along with java.io.io. So again, more streamlining. It's just really good stuff. So that's the on-ramp. Construction. Everybody is told when they learn Java that you can't have any code before the call to this or super at the beginning of a constructor. This rule was put in place at the beginning of time to prevent old timers from stomping on data that might be modified in a call to the superclass constructor. And it served us fairly well into the modern era, but now the gods of Java have found a way to relax the rule just a little bit. You can now have code before the call to super, as long as it doesn't try to call instance methods. It can assign fields, and most importantly, it can, and I find most useful, it can do validation. It can also call methods in other classes, not in the current class. Cannot call instance methods. Why not? Well, clearly because the whole point of constructors is that they require all the construction to be done before anybody gets their mitts on the instance. And that includes code running in the instance. So code, even in the constructor, cannot call instance methods in the current class. It can do almost anything else, but not that one thing. There always has to be some restrictions, right? And this one is for your own good. So let me switch over to the IDE here and get into the right window. So I have here, oh, before I do that, I'll show this bit here, which shows the calling sequence when you call, say your application calls a constructor for a subclass. Well, in the old days, the before method, the before version, the subclass would immediately call super constructor, and the super would immediately call its super. Say there's only 2 levels, so that super would be object. Object constructor simply returns immediately, and the superclass constructor does its initialization, and then the subclass does, and then and only then the app gets a reference to the new object. Well, similarly now, except that when the app calls new subclass, the subclass constructor does its prologue. The prologue is the part before the call to super, and the epilogue is the part after. So the subclass constructor does any prologue statements it has, then calls super, and the superclass constructor does any prologue it has, then calls super. Object returns, then the superclass does its epilogue, and the subclass does its epilogue. The epilogue is the stuff that would normally have been in a constructor in the past. And the prologue is often where you put stuff like validation and so on. And then and only then the app gets a reference to the finished object. So here's an example. We have a class called 1, kind of unimaginative, and a superclass of it called 2, and it has a field in it called in the top level class called day of month, and its constructor is called with that. And here's the validation part, doing this before the call to super. If the day of month is negative, 0, or greater than the longest month in our calendar, we throw an exception. Otherwise, we go ahead and do super. This is key for performance, because oftentimes the superclass constructor will do something expensive. And if you can avoid that by validating before it gets into it, then you save all that overhead. We did a little bit of an epilogue here, just taking the day of month that we got in here and saving it in the field. Class 2 just takes the local date and gets the day of the month and passes that into the superclass constructor. Again, you couldn't have done this prior to before statements before constructor, before super, because that would say super has to be first thing. When most of you learned Java, that was the rule. But now you can do things like that. And the main program just calls it and prints out. Just going to print out 23 because that's the 23rd today. You could do any other calculation or anything else like that that you needed. This one, another example, just doing the field initialization before the call to super. And that's all legitimate nowadays. This one tries to call toString inside the constructor. That is not kosher. That is not allowed. If I try that, I used to be able to type. Here we go. Right away it flags it because it says you can't call statements, can't call toString before the superclass constructor. So the IDEs have done a fairly good job of following along with these syntactic changes and being on top of them. I call out there the potential problems with setting inherited fields. If, say, last name or first name were an inherited field, it would be possible for the superclass constructor to overwrite what you've done. So I generally don't put assignments before, direct assignments to fields before the call to super. You can if the case is simple and there's no nothing else that it's going to run into, get overwritten by. But it's simpler to put them after. So that wraps up that. Code to super is considered to be pre-construction or prologue, and the prologue is limited. It can do a lot of things, but it cannot call instance methods. The JEP for this, by the way, is 447 for Java 22 when they introduced it. on to the next section, text blocks and javadocs. You can tell I like things that rhyme. So text blocks, I did give one example already. These are multi-line strings. They're wrapped in three triple quotes, the first of which must be on a line by itself. That new line does not become part of the string, but other embedded new lines do. The line is unindented to the least leftmost, if you will, string. This old version is the way we used to do multi-line strings. Quote, \n plus at the end, quote, \n plus at the end, and so on and so on. This is the new way, much easier, much simpler. And just to show that they're the same, I print them both out, and at the end I call equals. And sure enough, equals returns true. So it did, in fact, these two did, in fact, format or generate exactly the same string. And that's pretty neat. Also, you can use single or double quotes inside the string without having to worry about quoting them, escaping them. That's another benefit, simplification. The other part of this section is javadoc. And javadoc continues to evolve. I'm sure most of you are probably familiar with javadoc. You've either written javadoc code or at least looked at it in code you're maintaining. One recent addition is something called snippets. And a code snippet is a little bit of actual code in Java or some other language, like Shell or Perl or Python or whatever you have to use in conjunction with Java. And you put that in to your javadoc code, as shown here, curly brace around the whole thing, and then at snippet, specify the language. Default is Java, you can leave it out. A colon, and then some body of code, which you notice my IDE is highlighting for me. And that's going to appear in the generated javadoc as a code block. And that I can show you. I could show you, but my Firefox got restarted. So I won't show it right now, but you've probably seen these if you've looked at any recent Java 21.2.3 javadoc little code blocks that have a copy block on them. You don't have to carefully select the lines and do Control-C. You can just hit the copy button and it'll copy exactly what's in the code snippet and nothing else. Also, javadoc comments can now be written in a proper text formatting language called Markdown, one of several text-based languages. Markdown has been in use for decades, a decade or so at least. A lot of GitHub projects use a readme.md, which is formatted, which produces the formatted page you see at the bottom of the first page of any GitHub project. Markdown is written as plain text with empty lines between paragraphs, no .p or angle bracket p or anything, and uses a couple of stars for boldface, a couple of underscores for italic, dash for list, and a few other formatting elements. To tell javadoc that a given comment is Markdown based, all you have to do is put slashes in front of every line rather than /*, 3 slashes in particular. So there's an example. This is the same thing done in HTML and in Markdown. So there's a title, there's a comment with bold in it, and there's a itemized list. And that is going to appear in the javadoc as a list. And this is going to come out in bold. So I do have a make file. Maybe I can run that. There we go. So there is my new javadoc example. And you see not showing it. I'm guessing that it's running with the wrong version of Java, which I apologize. Let's see if this one worked. There at least is my snippet demo working. So there I just have to click this copy button and it'll copy the exact contents of the snippet. Incidentally, you can mix and match within a file. You can have, well, you can see it here. I have a mixture of Markdown and traditional javadoc comments. They both coexist peacefully, which is a good thing because it means you don't have to go and rewrite everything at the same time. On records. The average developer, Java developer, spends about 17% of their time writing POJOs, plain old Java objects. Some of these, I made up that statistic, but it's probably close. Some of these objects are heavily modified during use via set methods or, like some other languages, just by assigning to or fetching from fields. Many other objects are just used as, for example, data transfer objects, where they're created over here with some data that's available here, sent over to here, and then deconstructed or worked on. Those ones don't need to be modified. And if you can make objects that are known to be immutable, meaning they cannot be changed, then it makes your code a bit more reliable. It's easier to reason about what the code will do. You don't have to worry about multiple threads modifying the same data at the same time. And memory reduction, because you can share objects within your application. Functional programming languages typically support widespread use of immutable. Some of them completely avoid support for mutable objects altogether. Java can never get there because there's too many, set and get methods that have been written over the years. But interesting anecdote, I was once working on a reasonable sized project and that had been written in the early days of Java before IDEs were commonly used to write the setters and getters. They were written by hand or more commonly by copy and paste. I did a study and found that about 0.5% actually returned or updated the wrong field. Now the application still worked, so there must have been fields that were never used. I can't explain that, but I did notice that a lot of them, a fair number of them, a couple of dozen, were wrong. And so writing accessors, I think, will become less popular, less common. Introduced as a preview in Java 14 and 15, the Java record became official in Java 16. It allows really low code creation of read-only POJOs. All you have to do is declare the fields. So the getters, the equals, the hash code, the toString, and so on, you don't have to write any of those. They're all written magically for you. Because there will never be setters, all the fields are automatically final and have to be final. You can't make non-final variables in a record. Because of that, the auto-generated getters don't have get at the front of them They just have the name of the field with parentheses to retrieve it. Here's some examples of that. So starting off here, let me make that bigger so you can see it better. Record customer, string first name, string last name, int customer ID. So that is all, literally all you need to do to provide the Pojo. It has to have, it is a class-like thing, a class, so it has to have a body, but the body will typically be empty like it is here. And then just fields. In the main program, we construct an object just like any other object, calling the constructor. We can then access fields by their field name with parentheses. That's the get method, the accessor. You can print the full record. That'll toString it, and we can print out the whether it's equal to some other object. Hopefully that will be false, different than that one, and the hash code. If I run that, we see that, sure enough, hello name comes out. The full record, this is the toString, generated automatically for you. Fields typically come out in the same order you wrote them, and it's just a nice, convenient default toString. Equals returns false, obviously, and hash code returns that typical looking hash code value. Not a very interesting number, but there it is. You can, of course, override methods because it is a class. So inside the body, you can put methods. Here's one where I write my own toString, just printing out the first name and last name and not the customer number. And I then change the order around, print the name, first name, last name in backwards order, just to keep things interesting. And let's just run it and turn off. So now my toString looks a little different, a little more readable, and that's all you need. Bingo. You can even have constructors with one caveat. Just like normal constructors have to call super or this, the record constructor has to call the real constructor. So here's an example. I have a simple class of type record called foo, which has a name. And in here, I create the standard way. But then there's more stuff down below. I have another main method called main2 that doesn't actually get run unless I run it. And it creates a bar, and one with a string and one with a integer. That's interesting. So here we're showing that the record can have a non-canonical constructor. The canonical is the one that is provided for you based on your header. And this one is an overload of the constructor, that instead of having a string, it takes an int. It just does the conversion, integer.toString, integer.toString, and then passes it to the canonical constructor using this. So again, fairly straightforward and very useful. Now, the one limitation is that there absolutely are no modify methods. They're completely immutable. What if you need to change an object at some point? Well, it turns out you can do that. The normal pattern for doing that is to write a method called with. And this is technically called the withers pattern, which some people pronounce withers, which is what's on a horse. I don't know. Anyway, the with pattern. I used to call it the with xxx pattern, meaning variable. And so we create a customer with a different last name. Why? Because someone got married and changed their last name, right? So we have to change the record. The with last name method takes the new last name, and how does it work? It's inside the constructor, it's inside the record rather. So it simply returns, create a new customer using the field from a mixture of the field from the enclosing record and the new data being passed in. And in fact, I'll do that. I'll change my last name to Smith. Common pattern, object equals object dot with. That's kind of the standard pattern for this. With and then the name of the field. So I'll print that and I'll make that change and then run it through name reversed. And sure enough, it's changed my last name from Darwin to Smith. Probably not a good idea for me, but there it is. There's an interesting point here, which is this works well with this customer that has 3 fields in it. What if you have like 20 or 30 fields? Might not be such a good idea. So there is talk that Java 25 will have a feature like this. This is definitely not committed by any means yet, but this is what they're talking about doing. Assuming you have your customer object, you can say customer object with, that's the with pattern again, but now we don't have to write any code other than a little block that says customer number equals new value. And I haven't tried this, but I think you can put more than one. Whatever, doesn't matter. So yes, but I can't actually run this because it's Java 25 and I don't have Java 25 yet. But I think that's what it's going to look like. So that will eliminate the need for writing those as methods and simplify. You're beginning to see the overall trend here. Simplify, simplify, simplify. So threads. Everybody's probably familiar with threads. They've been in Java since before the 1.0 release. The path they have followed is interesting, however. Funny thing, in the beginning, on some platforms, Java used native threads, but some operating systems, mainly Windows and maybe OS2, didn't make threads available to developers. So Java had to use its own green threads library. I don't know why they called it green, but anyway, the green threads library implemented its own time sharing internally inside the JVM. Over time, all the other operating systems conformed to making threads available, and so green threads was kind of put on the shelf. Now, regular threads are widely used in Java, as probably most of you know, but they are fairly heavyweight. They are tied to an operating system thread, and that limits the number of concurrent operations. For example, in a web server, you can't have too many requests coming in concurrently. So virtual threads are the answer to this. They're almost back to green threads in the sense that they are managed internally, but they are multiplexed onto platform threads, which are then called the host or carrier thread. Apart from how we create them, they're almost indistinguishable from platform threads. They're represented by instances of the thread class, but they're created differently. If you want one, you call the static thread method start virtual thread with a runnable, just like calling the thread constructor with a runnable gives you a regular thread. Thread.start virtual thread gives you a virtual. If more commonly you want a thread pool, to be virtual, you say executors.new virtual thread per task executor. I don't know who came up with that name. It's kind of long, but there it is. Executors.new virtual thread per task executor. The key thing is that, and the key performance win, is that virtual threads are disconnected from their host thread when they're blocked, and they can't do anything, mainly on I/O. The host thread will immediately pick up some other virtual thread and run it, finding one that's ready to run. This can be a big performance boost by using multiple threads, particularly if tasks like web servers that are doing lots of I/O. Maybe less of a boost for CPU-bound tasks. The following demo is a simple one that tries to illustrate this. I'm not sure I trust the numbers coming out from it yet. I haven't really studied it enough to be sure, but I'll run it anyway. There's a somewhat longer example. It is writing to a buffered writer to get from files new buffered writer with the file name. And I have two runnables that I'm going to use. One of them is the I/O bound and one is the CPU bound. The I/O bound just writes to this file one character at a time, which is inefficient. And this one, the CPU bound one, just updates a static, public static int. I made it public static so the compiler can't know that it's bogus and optimize it out of existence. Anyway, I'm going to run both the I/O bound and the CPU bound on traditional threads and then on platform threads, on virtual threads. So that's all this does. Create a new cache thread pool and run the I/O bound, and then create a new virtual thread per task executor thread pool and use that for the I/O bound. And I just do the same thing for the CPU bound one, just inline the construction of the thread pool. So each one gets its own new thread pool. And the CPU task, sorry, the take time method here throws up to 100,000 instances of the thread into the thread pool, and then shuts down the thread, closes it, waits for it to finish, and measures the time before and after. So let's run that guy and see what happens. We find that the I/O bound cuts it in half, and the CPU bound cuts it down by about five and a bit. So I'm not sure I trust that number just yet. I need to do a bit more research. What I would suggest, if you're doing this, take this timing mechanism and apply it in your own application, or use a fancier profile. This is really rock bottom. Elapsed time. Doesn't account for CPU time, of course, because we're using multiple threads, but it's just a quick and dirty measure. So don't take it too seriously, but there it is. Last major topic. Come on there. There we go. Has to do with switch. So the last several years have seen a continuous upgrading of switch and instance of together in Java. First of all, there's something called a switch expression that allows a switch statement to return a value instead of having to process it individually. That one got closed somehow. Sorry about that. So starting with an expression switch, we have a enum for the colors of traffic lights, red, yellow, and green. We have a main method that calls action from color, old and new, passing the same value in. The action from color is going to do its own printing, whereas the action from color new is going to return a string. And lo and behold, the action from color, old, has a switch on color red, color amber, color green, and does the obvious print thing. And each one has to have a break. Remember, big failure point in people learning to use switches or doing them in a hurry is that you forget the break and it falls through and prints two of them, or something more drastic. This one also has a default because somebody might add a flashing or something advanced green or whatever into this enum, and if they forget to modify the code here, it would maybe do nothing. You want to prevent that. The new version, you notice, is quite a bit shorter, and there's a couple of reasons for that. One is that the return statements and the break statements are both not needed. Just each one has a semicolon. These look sort of like lambdas, which is effectively what they are. They're expressions that get returned. And for enums or anything else where all the possible classes are known, you don't need a default because the compiler will check it. So if somebody adds flashing advanced green to this enum, and this code won't compile until they get around to updating it. I see it's now 1 o'clock, so anybody that has to go and join the other session that's starting now, feel free to do so. I will not be upset if you drop off now and go and see the other session, even though mine's more interesting. Now, pattern matching, not to be confused with regular expression patterns or string patterns, lets you combine an instance of and a test, which is we have our usual shape, circle, rectangle trilogy. And this is a really bad example. It's just to show the syntax, not something you would really do in real life. We have a compute area that takes a shape as an argument. And if it's a circle, does the pi r squared thing. And if it's a rectangle, do the width times height time thing. The old way is shown here, commented out, just because I didn't want to try running it. The pattern matching way is the following. If S, which is the argument passed in, if it's an instance of rectangle, then instead, or say if it's an instance of circle, I should do that one first. If it's an instance of circle, then assign it, cast it, and assign it to the variable ci. And then I can use it in my immediate following statement, ci.radius, pi r squared. Forgot to multiply it times itself, but you get the idea. We're working with it. And similarly for the rectangle, if it's a rectangle, if it's an instance of rectangle, create a variable called rec, assign this to it, and write the cast in for me. And for this one, we do have an else clause. And the main just creates a couple of them and prints them out. Does what it's told to, which isn't necessarily the right thing. Anyway, I'm sorry that's not the best example, but it's what I could think of. Record pattern matching takes it one step further and lets you deconstruct the actual field values rather. So in this version, print person old, we'd have to say if O instance of customer, downcast O to customer, save it in the customer, and then call methods to get the individual fields, to deconstruct the object into these fields. In the new form, we simply say if O instance of customer, we list here the local names that we want used for the types, which of course have to match what are the fields in the constructor for this customer. And it deconstructs them automatically into these local variables. Instead of having to have all this stuff, we just do it in one line. This is really important stuff for reducing code. A lot of things in this that I've talked about here so far are for reducing code. Don't forget, the less code you write, the fewer typos you make, the less code you have to read when you're debugging, and the less code you have to read when you're maintaining. So these are all really good things to know, and that's why I'm including them here. So without further ado, data-oriented programming, or DOP for short. Data-oriented programming doesn't count as one of my 6 or 7, whatever it is, main topics, because it's a combination of a bunch of them. There's strong synergy between records, the modern switch statement, sealed types, which I haven't covered yet, an instance of pattern matching that leads to a new minor paradigm called data-oriented programming. It's new, it's exciting, it's sort of a departure, a move sideways from object-oriented programming. OOP is still needed for some applications, but not others. If you want to hold your excitement, you can come back tomorrow for Ken Cousin's talk at 1300 or 1 o'clock Eastern time tomorrow. He's talking about DOP in conjunction with RESTful web services. Otherwise, if you don't want to wait or can't make that talk, there's an article here by our friend Brian Goetz over at Oracle on this is kind of the paper that introduced data-oriented programming to the world. So that's kind of definitive. But wait, there's more. This is a picture of my late great boss, Yuri Rubinsky, who, among other things, founded a startup company that I was working at when I first ran into Java. Yuri spent his life working for accessibility and information survivability while steering SoftQuad, the small company, the startup, into SGML, Standard Generalized Markup Language, and convincing the world to use SGML. SGML turned out to be too complicated or too general. That's the G in SGML. But it was cut down to make a couple of technologies you've probably heard of. One is HTML and the other is XML. And I did say that he spent his life doing that. He literally worked himself to death, eating too much airport food while shuttling around the world, pushing SGML, and passing away from a heart attack, unfortunately. So rest in peace, my friend. Anyway, I did say there's more. There's so much more in recent releases of Java. I had to limit myself to covering half a dozen of them, but I will mention a few briefly in passing. Java 14 brought JPackage, which is a tool that makes up an installer to install your desktop software on client machines. It generates an installer that is native to Linux, Mac OS, or Windows as appropriate, and which includes a custom minimized JDK that is a version that works with your application. So users are freed from having to worry about keeping their JDK up to date or getting a version that's incompatible with your app. I use this in an app of my own called PDF Show, which is for presentation from PDFs, and it works nicely. You do have to run it on Windows to make the Windows app, and on Mac OS to make the Mac OS app, etc. That's fairly standard. There's a new API called the class file API that is for accessing and creating binary.class files. It's kind of like Reflection, except it's more aimed at reading and writing. Structured concurrency lets you manage groups of related thread tasks as a single unit, easier than trying to manage dozens of separate threads in a large application. That was explored in Hanno's talk at 9 o'clock this morning. The foreign function and memory API lets you deal with native code like C and C++ much more easily than the older Java native interface, and also lets you share memory with libraries written in other languages. Improved concurrency utilities always improving that. Java util concurrent package, performance optimizations in the JVM and the JIT compiler continue to improve performance. One study wasn't a very thorough study, but it did compare applications, found about a 30% improvement just between Java 17 and 21. That was a web application using Quarkus or Helidon, one of the REST frameworks. Continuous integration to improvements to security, stronger secure random numbers, more algorithms. In the streams area, stream gatherers, sealed types, classes and interfaces to restrict subclassing. And being proactive, they have actually added post-quantum encryption algorithms. So there really is a ton of new stuff happening in Java, in new releases of Java. I've tried to cover some of the most important or favorite to me anyway of them. I've given you a list of all of them. There is a complete list here in this book, which is coming out on March 18th, which is the same day that Java 24 is coming out. And in the appendix, there's a detailed list of the new features in all releases from 16 to 24, showing you what came in when and when it was in preview and when it came out of preview and so on and so on. Just so you will hear about these, OpenJDK is loosely organized into a bunch of projects. Four of the main ones are listed here, and the different APIs that either have come from them or are coming from them. And that's pretty much it. So I'm going to open the floor for questions, and I'm hoping that Mary will tell me if there's questions coming in from the chat.
Yes, that's right. Thank you so much, Ian. It's a great talk, I'm sure. I mean, more than great, it's super amazing. So thank you. And actually quite a few folks are staying too. So thank you to all who have been staying here. I'm trying to scan through too. I think it looks like I do not see any specific questions.
Good.
And folks, please send your question if okay. So there's been a bit of a discussion. Some folks talking about Lombard and the records and all these things. Bunch of more conversations among themselves, which is good. I think I see it's being great. Would anybody please indicate if you like to be sending your question before we end this session, I guess. So as I mentioned, I do not see any currently, but let me scroll back because there's been a bunch of conversation too. Let me see.
While you're doing that, I can address Lombok. It is a good thing, and it does some of what records do with a little bit more control. You can say, I only want getters, or I only want setters, or I only want a hash code, or a hash code and equals, I should say. It's implemented, by the way, as a compiler preprocessor. So, and you can actually write your own of those. It's a bit obscure, but I can't remember where I just saw a paper on how to do it. I'm sorry, I can't think of that offhand. But anyway, so yeah, Lombok is a good alternative. Records, I think, will gradually displace Lombok over time as the new JDKs become more popular.
That's right. So I'm just displaying a few comments from folks who have commented on Lombard and records. As I'm kind of scrolling through, because it's been a bit of a conversation. So in here, so I do not see any questions, specific questions. But correct me if I'm wrong too. Folks on this stream, and I still see like over 20 people online. So thank you so much. And I suppose if there are no questions, and again, this is how you can reach Ian, and it's pretty amazing. And I'm sure the conversations will continue after this session, and that's the whole purpose. We want to build up a community to continue talking with Java champions and everybody too who have participated. So there's a new comment. Oh, okay, just folks saying thank you. So just kind of thank you. Yeah, this one from Sadata. Yeah, and yeah, I see a couple folks very good, and I'll just try to display them. Vincent also says great, and I'll just try to display a few of these, and also Letitia. So yeah, I think if we are good, then we can close this session, unless you have some more questions. And yeah, I'll kind of give a couple more seconds. Yeah, if not, then I will end this session. So
Thank you, everybody, for attending, and we'll see you again.
Yeah, thank you. Yes, okay, great. All right. Okay, bye. I'll just end the stream now.